Hello viewers, in this class we are going to solve one problem related to the equation of the plane, right? And here we are given some conditions to find the equation of plane. So let us take the problem. So find the equation of the plane passing through the point 1 comma 1 comma minus 1 and perpendicular to the planes x plus 2y plus 3z minus 7 equal to 0 and 2x minus 3y plus 4z equal to 0, right? Now here we have to find the equation of the plane which passes through this point, right? So let x1 y1 z1 is the point 1 comma 1 comma minus 1, right? And the equation of a plane which passes through a point x1 y1 z1 is given by a x minus x1 plus b y minus y1 and c z minus z1 is equal to 0, right? So this is the equation of the required plane, right? So let us say that plane is pi, right? So pi is the plane which passes through x1 y1 z1, and here x1 y1 z1 is 1 comma 1 comma minus 1. So let us substitute it here. So we have a x minus 1 plus b y minus 1 and c z plus 1 is equal to 0, right? So this is the plane. Say this is our plane and this is the point, say 1 comma 1 comma minus 1, right? So this is our required plane. Now here we are given two conditions, or we are given two planes, and this plane pi is perpendicular to this plane and this plane. So let us call this plane as pi 1, and this is x plus 2y plus 3z minus 7 is equal to 0, and pi 2 is the plane 2x minus 3y plus 4z equal to 0, right? Now this plane is perpendicular to these two planes. Now here A, B and C are the drs of the plane pi, and these are A, B and C, right? So suppose this is the normal vector to the plane pi, right? And the drs of this plane are A, B and C, right? Now the drs of the plane pi 1 are given by the coefficients of x, y and z. So the drs are 1, 2 and 3, right? And the drs of the plane pi 2 is given by 2 minus 3 and 4, right? Now here we know that if two planes are perpendicular, right? If two planes are perpendicular, then their normals are also perpendicular. So if two planes are perpendicular, then their normals are also perpendicular. So here let us draw the plane pi 1, right? Suppose this is the plane pi 1, and see here this is the plane pi 1, and the normal to this plane pi 1 may be drawn like this, right? It may be drawn like this. So this is the n1 vector. So we see that n1 vector is perpendicular to n vector. So if two planes are perpendicular, so here this plane pi and this plane pi 1, and these two planes are perpendicular, then their normals are also perpendicular, right? Similarly, this plane pi 2 is perpendicular to this plane pi, and we again conclude that if n2 is the normal vector to this plane, then n2 is perpendicular to n vector, right? So the plane pi is perpendicular to pi 1 and pi 2. So the normals n1 and n2 are also perpendicular to the vector n, right? And we know that if the drs of two vectors are, say, a1, b1 and c1, and a2, b2 and c2, these are the drs of two vectors which are perpendicular, then the condition for perpendicularity is given by a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So this is the condition for two vectors to be perpendicular, right? So now here we have n1 vector is perpendicular to n vector. So the drs of n1 vector are 1, 2, 3, and the drs of n vector is a, b, c. So by this condition we have the equation a times 1 plus b times 2 plus c times 3 is equal to 0, right? So again n2 vector is perpendicular to n vector. So again by this condition we have a times 2 plus b times minus 3 plus c times 4 is equal to 0. So we have two equations in a, b and c, right? So we can write these two equations as a plus 2b plus 3c is equal to 0, and here we have 2a minus 3b plus 4c is equal to 0, right? So here we have these two equations, right? Now let us call this equation as equation alpha, right? Okay, now what we will do, we'll eliminate any of the variable a, b or c from these two equations, right? So let us eliminate b from these two equations. So what we will do, we'll multiply it by 3, this equation by 3, and we'll multiply this equation by 2, right? So what we will get, we will have 3a plus 6b plus 9c is equal to 0, and here we'll have 4a minus 6b plus 8c is equal to 0, right? Now we'll add both these equations, and we find that we have 4 plus 3 7a plus 17c is equal to 0, right? Now 7a is equal to minus 17c, right? Now we can take 7a is equal to minus 17c is equal to lambda, where lambda is some scalar, right? Okay, so now from here we have 7a is equal to lambda and minus 17c is equal to lambda. So a is lambda by 7 and c is equal to minus lambda over 17. Okay, now we'll substitute the value of a and C, which are now expressed in terms of lambda, we'll substitute these two values either in equation 1 or in equation 2. So let us substitute it in equation number 1. So therefore we have lambda over 7 plus 2b, and then we have minus 3 lambda over 17 is equal to 0. So 2b can be written as 3 lambda over 17 minus lambda over 7, and this can be simplified as 21 lambda minus 17 lambda over 119, right? So we have 2b is equal to we have minus it is 3 lambda, so this is 21 minus 17, that is 4 lambda over 119, and 2 2s are 4, so b is equal to 2 lambda over 119, right? So now we'll substitute the value of a, b and c in equation that is in equation number alpha. So here we have lambda over 7 x minus 1, then we have b, that is 2 lambda over 119 y minus 1, and then we have c, that is minus lambda over 17, and here we have z plus 1 is equal to 0, right? Now here lambda is some scalar and lambda is not equal to 0, so dividing throughout by lambda we get rid of lambda, and then we'll multiply the entire equation by 119. So what we will get, so here we'll have 17 times x minus 1, here we have 2 times y minus 1, and here we have 7 times z plus 1 is equal to 0. Now simplifying it, we have 17x minus 17 plus 2y minus 2 minus 7z minus 7 equal to 0. So we have 17x plus 2y minus 7z, and this is minus 17 minus 2 minus 7, so it is minus 26 is equal to 0. So the Cartesian equation of the required plane pi is given by 17x plus 2y minus 7z minus 26 is equal to 0. Now the vector equation can be written as vector r dot, and here we have 17 I cap plus 2j cap minus 7k cap is equal to 26. So this is the required vector equation, and this is the Cartesian equation.